Hey everyone, and welcome. Today, we are jumping into one of the wildest frontiers in tech. We're talking about the moment AI stops just thinking inside a computer and actually starts doing things out here, in the real world, with us. So, let's just kick things off with this massive question. What if AI could literally step out of the digital realm and start interacting with our world, just like we do? This isn't some far-off sci-fi dream anymore. It's what's happening right now, and it's called embodied AI. So to really wrap our heads around this, here's our game plan. First, we'll look at what it even means for an AI to get a body. Then, we're going to dive into how these machines actually see and make sense of reality. After that, we'll check out some incredible real-world examples. And finally, we'll get real about the big challenges that are still on the horizon. Okay, first things first. AI gets a body. This is that huge leap, right? The moment where pure and visible code gets a physical presence. For the longest time, AI has been what you'd call disembodied. Think of it like a brilliant brain just floating in a jar. It's a supercomputer that can process insane amounts of data, spot patterns, read an essay, but it can't pick up a coffee cup. It's totally disconnected from the physical world. And that's where embodied AI comes in. This is the big moment. It's when we take that AI brain and we put it into a physical body, a robot, a drone, a self-driving car, you name it. And that body has sensors to perceive the world and actuators, things like motors and grippers, to actually act on it. All of a sudden, that brain isn't in a jar anymore. It's right here in the room with us. But, to act in the world, an AI first has to perceive it. So how in the world do you give a machine senses? Well, that takes us right into our next section, how machines perceive reality. So an embodied AI has this whole suite of tech senses. Computer vision is its sight. Haptic perception gives it a sense of touch. Auditory perception lets it hear. But the real secret sauce, the magic, is something called sensor fusion. See, it's not enough to just have eyes and ears. The AI has to blend all that information together into one single coherent picture of reality, just like our brains do. That's what turns a flood of raw data into actual awareness. And one of the biggest game changers here isn't just seeing the world, but actually understanding it in human terms. By fusing what the robot sees with language, it can connect an image of an apple with the word apple. And that's what allows it to follow a command like, hey, go pick up the red apple on the kitchen table. And this gets even more sophisticated. Just look at how AI learns to tell things apart. On the left, you've got semantic segmentation. It basically lumps all similar things together. So if it sees a crowd, it just labels everyone person. Simple enough. But on the right, instant segmentation is way smarter. It sees each person as a unique thing, person 1, person 2, person 3. And that distinction is absolutely critical if you need a robot to interact with one specific person in that crowd. Okay, so the AI can see the world, it can sense it, but how does it learn what to actually do? Well, this is where it gets really cool. Let's talk about learning through interaction, because this is all about how these machines get experience. And a huge part of that is something called reinforcement learning, or RL for short. Honestly, the easiest way to think about it is like training a puppy. The AI, the agent, tries to do something. If it gets it right or gets closer to its goal, it gets a reward, a virtual treat. If it messes up, it gets a penalty. Now, the reason this is so revolutionary is because the real world is messy. It's unpredictable. You can't possibly pre-program a robot for every single thing that could happen. But with RL, it can learn and adapt all on its own. And this right here is that learning process in a nutshell. It's a constant loop. The robot observes, it acts, it gets feedback, good or bad, and then it updates its internal rulebook, what the pros call its policy. And every single time it goes through this loop, that rulebook gets a tiny bit smarter. Over thousands or even millions of tries, it can master some unbelievably complex tasks. All right, so we've covered the theory. Now for the really fun part. Let's look at embodied AI in action and see how this stuff is already changing everything today. I mean, just look at this table. It gives you a great snapshot of the sheer impact. This isn't happening in just one or two niche areas. We're seeing it in manufacturing, predicting when machines will break down. In healthcare, it's helping surgeons and keeping an eye on patients. Even in retail and finance, it's making supply chains smarter and sniffing out fraud. The applications are everywhere. So let's get even more specific. We're talking about autonomous vehicles navigating our crazy city streets. We're talking about drones doing everything from search and rescue missions to helping farmers grow crops more efficiently. In factories and warehouses, robotic arms are the new backbone of logistics. And in our hospitals, these systems are becoming vital tools for everything from physical therapy to complex surgeries. And if you want a sense of the sheer scale of this change, just look at this number. The market for autonomous vehicles alone is projected to be worth $1.2 trillion by 2030. This isn't some small-time tech. This is a massive economic force that is actively reshaping our world as we speak.
And you knew there was a but. It's not all perfectly smooth sailing. We've got to stay grounded. So let's turn to our final section, the challenges on the horizon, and talk about the very real hurdles we still have to clear.
And these challenges are no joke. On the technical side, just keeping these things powered up is a huge problem. All the sensors and processors are incredibly power hungry. Security is a massive concern. What's to stop someone from hacking a self-driving car? Then there's the data problem. You need mountains of good, unbiased data to train these things, and that's hard to get. And that brings up the really thorny ethical questions. When an autonomous system messes up, who's to blame? The owner? The programmer? The company that built it? We don't have easy answers for that yet. And this quote right here, it just nails the security problem. A lot of these new AI systems have to plug into older systems, legacy systems, that were built decades ago, long before anyone was thinking about sophisticated cyber attacks. And that creates these gaping security holes that are just waiting to be exploited. So what it all boils down to is this. We are in a sprint to innovate, which is exciting, but we absolutely cannot afford to let safety, security, and ethics lag behind. The only way forward is to find that careful balance, making sure that as these systems get smarter and more capable, they also get safer and more trustworthy. And that really leaves us with one final big question to chew on. As these intelligent machines get better and better at navigating our messy, complicated human world, the biggest challenge might just be for us. How are we going to learn to live and work and thrive right alongside them?